Hello, I am Vikrant Rathole, partner of OOB Consulting, and VRiddhi estimation software has been designed by us, and we are also selling it in the market. So, in this video, we will be covering on milling operation. Previous videos we have covered as turning operation. So, in this video, we will be covering milling operations. To save time, I have already added one machining center, and we will move ahead with add operations with that. Just enlarge the screen. Okay. The operations covered in milling machine is boring, burnishing hole, drilling, face milling, idle. If you have seen previous operations introduction video, idle is something like if we are not covered any of the operations over here, you could consider this using idle. Key in the minutes what they require to perform this operation and move ahead with the calculations. Then we have profile milling. Profile milling is nothing but if you know how much volume is to be removed, then we could work on material removal rate. Frankly speaking, this is not the appropriate way to calculate the cycle time. The reason is your cycle time is totally dependent on the tool path movements. So, if you have gone through all the previous videos, you will understand like MRR is not the right method of calculating the cycle time. And this is one of the reasons why most of the CAD CAM fail, because they can give you accurately the length of cut, but they cannot calculate the the right timing. It is always approximate. And also your acceleration and deceleration works on each and every movement what you do. Your CNC, how it behaves to all the information what it collects, it also plays an important role. Probably we will write some blog someday on this. So profile milling is working on material removal rate, MRR. Then we have is reaming. All this whole operations we will cover it in a separate video. Then we have is a rectangular boss. So suppose if you have a rectangular boss which is to be machined, then these are the parameters that you have to key in, and we will automatically calculate the cycle time. Then we have is a rectangular pocket. Key in the pocket dimensions, and we could calculate the cycle time for this pocketing. In this pocketing, we have is lot of strategies. We will come in details in that very soon. Then we have is round boss. That is a round boss is there, and there is then peripheral material to be removed. Then we have is a round pocket. So if you have to do is pocketing of an circular this thing feature, you could use this. Then we have slot milling, and finally tapping. Tapping will also be covered in our whole machining operation. So let's start with face milling. As soon as I select face milling, we are ready with all the parameters. If you have watched the turning video, you would understand like what are the key inputs that has been required. Then the next operation I do is selection of the tool parts. Straight and conventional, that is nothing but you go along single direction, return back, take the second overlap, move again. So if you are using is a conventional milling machine, this will help you to find out the cycle time with that. Then we have a Zig Zag movement. So your tool parts and cycle time will be based on the Zig Zag tool path strategy. Then you have is counter, and finally the spiral. So these are the four strategies what we could work around with face milling operations. As you have seen in turning, we could also have is two tool selections done over here. So let us start with this operation. Straight and conventional. I will use a single tool at the moment. First we cover the single tool and then enter into the two tool operation. Unfortunately, I don't have the milling cutter already feed into this, so we will start keying the details. So I will take as 200 the surface feed, then 0.06 will be my feed per tooth. You could see it over here, feed per tooth. Surface feed in meters per minute, feed per tooth in mm, and all other dimensions in mm. Depth of cut I would like to keep is say 1 mm. Tool diameter, let us take 25. Tool diameter plays a very important role in the total tool path calculation and also the number of teeth in terms of timing. 6. Tool overlap. Tool overlap is the between two successive this thing machining. What is the overlap that you are going to take? So if you are going to use 100% of the tool diameter and offset it for the next this thing lateral cutting, you could put it 100%, or the way how you are going to use it. If you are going to use just 20% of the tool overlap as an AP, use it. So we will keep it at the moment 100. I am not limiting the RPM at the moment because you know how to use this limit RPM. Now let us calculate. You have got this 100 mm width of the face is again 100 mm. Let us take it in square. We have to do end milling for, and depth, that is the depth what is to be removed. So depth let us keep is 3 mm. This one of the option has been kept, like sometimes some of the programmers like to relieve the tool after every cut. So if the z-axis clearance is more than what you have kept in safe distance, it will be considered this. So this is sometimes required because maybe there is some obstruction in between, and then you need to take the complete full Z up. So that is what is essential over here. Purposely, I have not kept in any safe distance over here because we will check how the safe distance makes an impact on the complete costing. I will put this first to conventional. So the input is good, fine to go. Let us calculate operation cost. So to machine in 100 by 100, 3 mm deep, using in 25 die a 6 tooth cutter with 100% overlap, the total length of cut is 2124. If we move from conventional into zigzag, calculate operations, this is your total cut length, and if you see this, your non-cut length has gone down. Again, let us have the, sorry, because here after every movement of the cutter it will come back, second, come back, third, come back, fourth, likewise. Now as you see, since this is happening, because since it is an 25 dia cutter and we have taken 100% overlap, there is practically only 4 lateral cuts what we have. If we increase the X and Y by 11 mm, you could see the drastic difference in the total timing, cut length as well as non-cut length. Because now what is happening, there is one more additional cut which has been getting added to this. We'll show you over here. There is one more cut which got added just because of the safe distance. And this is what practically happens in most of the machine shop. While calculating, you are not sure what is the safe distance what has been kept. And this keeps on adding to your total non-machining cost, or I would say it's inefficient cost of using this. So use this safe distance very effectively, practically on the shop floor also, as well as during estimation also. Now let us have a look what happens when I change the diameter. This is 25, let us put it 50. Now at 50 and 100% overlap, it should be practically, if I don't put X and Y, it will be practically only 2 number of cuts. This is what happens. If I go to 32 dia tool, now let us move with zigzag, calculate operations. Let us move to counter, calculate operation. This is length of cut what you will get. Let us move to spiral. That is the best strategy what you could do. That's how exactly it is. Now everywhere the tool diameter and overlap will play a very important role over here. Let us put this to 25 and calculate in spiral. 900 mm, that is the difference. If the tool overlap, I move it to 50%, what happens? 2400 is my cut length. So this is how you are going to use the machining strategy, and this really affects your shop floor calculation, because one of the thing why we decided to put tool pass strategy was the same thing. Okay, we were thinking it will be done in spiral mode and people were doing it in conventional mode, or they were doing it in zigzag mode. And after having a lot of setbacks, we decided to include this tool path strategy. Now let us have a look at roughing finishing with a separate tool. All the data what I am keeping, putting it over here is completely factual. Now what will happen based on this complete this thing, the only requirement is z-axis. Since it's an end milling operation, the finishing allowance is only, if you are only keeping it in finishing allowance in z-axis. So I'll keep it over here is 1 mm. The reason is I'm keeping depth of cut is 5, so it will take us 2 depth of cuts. So we will just alter it in check. I will show it to you. This is what the complete situation is. If I switch it back to 1, so this is how the time affects your complete manufacturing. So I think most of the things have been covered on face milling. Let us start with something new. Let us start with profile milling. As I said, it is just MRR, that is metal removal rate. So it will not make much of the difference for any of us. So let us start with rectangular boss. So now we are considering is an rectangular boss. So what exactly is this is an protrusion which is out, and you are going to machine this dark yellow surface, right? Again, you have the same strategies that you could work with. Let us start with zigzag movement. Surface feed 200.06. Cut 1 tool dia 25. Number of teeth 4. Overlap is 100. Not keeping any limit RPM. Machining length, that is D1. That is the total length over here. You could see it. That is this length from here to here, D1. So let us put it as 200. Machining width is 100, and we have boss length of 50 by 50 and height of 5 mm. Right, number of bosses, we'll keep it 1. If you have multiple bosses, you could say number of bosses is more than 1. Even if I keep it 0, it will automatically calculate it at 1. And this is what the whole cycle time will work to. If I increase the depth by 1.5, if I increase the depth to 3 mm, if I decrease the tool overlap 50%, %, which is normally most of the people are comfortable working with. So this is how the whole thing will work around. Again, you could go over there and change the strategy, maybe counter cutting. This is the impact what you could have. And the best strategy, that is spiral. So this is what you saw with the rectangular boss. Now in the same manner, let us look at round boss. So rectangular boss and round boss are almost similar. The only thing is this protrusion, what you see over here, instead of square, it is round. So what we do, we will be machining in zigzag, that is straight parallel manner up to the outer square of this circle, and then you will be using it in G02, G03. So I'll just explain you. Let us this time keep it 180 feed 0.02. That is feed per tuta. 1 mm tool dia 25. Number of teeth 4. Tool overlap 60%. Now machinable length, same what we saw it over there, maybe say 200. Machinable width is 200 and boss dia is 100. Boss height is 5 mm. Number of bosses, let us keep it 1. Calculate. This is the cut length what you will get. If we take it to 100 mm, So this is how the whole thing is going to work around. So let us start with one more operation, that is rectangular pocket. This is one of the toughest thing that needs to be done. In rectangular pocket, you have only two strategies, that is counter and spiral. So let us have a look at this also. I think the length of the video is getting much more larger, so we will continue in a separate video on rectangular pocket and this thing, square pocket. Oh, sorry, round pocket. Right, so we'll continue in the next video on this operations. So thanks for watching. We are eager to hear your comments and suggestions. Please keep writing to us, because your feedback is of importance to us, because we will be keeping on developing this software, and your feedback can help us in making the exact thing what you are looking at. Thanks for watching this video. Have a great day ahead. Thank you.